Okay. Number 5, which vector diagram best represents a cart slowing down as it travels to the right on a horizontal surface? Well, if I'm traveling to the right and I want to slow down, that means I need to be accelerating to the left. I need to be changing my velocity to become more leftward. In other words, I need to be applying a force to the left in order to bring my rightward velocity back down. Let me put it this way. Here we have the cart. And we say that this cart is going to the right. Let's say it's going to the right at 10 meters per second. Well, if I want to bring that thing down to rest, I believe that's what they're asking, right? Bringing it to rest? Oh, just slowing down. Okay, well, still, it still applies. We want to slow this thing down. What we're going to need to do is we're going to need to accelerate to the left, right? Because if I accelerate to the right, that means I'm just going to get faster and faster and faster. Let's say you have an acceleration to the right of 1 meter per second squared. That means every single second that passes, your velocity is getting bigger to the right by 1 meter per second. We don't want that. We don't want to be going faster. We want to do the opposite. We want to go slower. But if we have an acceleration to the left of 1 meter per second squared, that means every single second that passes, my velocity of 10 goes to the left 1 more meter per second. In other words, after 1 second passes with this acceleration, I wouldn't be at 10 anymore. I'll be at 9. Another second passes. Now I'm at 8. Another second passes. Now I'm at 7, and so on. Right? I'm accelerating more toward the left. My velocity is becoming not so much to the right anymore. It's pointing more toward the left. I'm slowing down. I'm approaching 0. So, to put this in terms of forces, if I want to accelerate to the left, in other words, I want to decelerate, I need to have a net force as per Newton's second law, right? Net force equals mass times acceleration. If I want an acceleration to the left, I need a net force that's happening to the left. So let's look at these. Let's see which one gives me a net force to the left. Well, first one, up and down cancel. This one, friction, is smaller than the force going forward to the right. Well, if that was the case, I would have a net force to the right because my force to the right is bigger than the force to the left. B is the complete opposite of that, right? The value of the force going to the right is smaller than the force going to the left, the frictional force. So if I look at this as a whole, my net force will be a small frictional force going to the left. Therefore, I'm decelerating. I'm accelerating to the left. So it has to be option B.